Okay, so we're going to analyze graphs. So what this one is, it says, what's interpolation and extrapolation? Okay, so first of all, what is draw a line of best fit? So there's just like a bunch of points here. And I'm going to draw what I think kind of fits the scenario the best. So what I'm going to do is I'm going to try to draw a line that kind of fits the best in there as it can. Something like that. Okay, yours might look a little bit different. Just try to draw a line that kind of fits center-ish as much as possible. You're not going to be able to include every single point. You're trying to make the best looking pattern you can that models it. So my grade 12ers in applied get to do this in their fancy calculator. Okay, so a line of best fit will help us find other info. So a person who has worked 15 years will make how much? So here's what I'm going to do. I'm going to find 15 years at the bottom. Which means I'm right here. And then I'm going to look across, and I'm going to estimate what that is for money. So they make about, on mine, $48,000 a year if they have 15 years experience. Okay, your answer is going to be a little different, right? Because your line might have been different than mine, and that's okay. So see, where does your 15 hit as a y value? So now, if a person makes 70,000, how long have they worked? I'm just going to go in the opposite manner. So if this is 70,000, I'm going to see how many years did they work? So mine is hitting around 32 years. Okay, and yours will be a little bit different, but that's what I'm trying to do. Okay, and then we have these words here. We had this interpolation and extrapolation. So what do they mean? This one was called the interpolation because did you notice that where I was working was within my data? Like the points were here. And then this one is extrapolation because look at where I am. I'm past my points. I'm past the data part. And now I'm having to extend and guess out there, right? Okay. Okay, does that make sense as a word? Inter, you're within, and extrap, you're out. You had to go extra to make your guesses, okay? So that's all those words mean. All right, physicsy people. Have you done something like this in science physics where you're doing like speed and time graphs, maybe? Yeah, oh yeah? Now or in grade 9? No. You're doing, and like literally right now? That's funny. Okay, so if this is a speed versus time graph, if the speed line is flat, 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 it means you're at a constant speed. And you know what I like to think about? Driving my car. This means I have my cruise control on. Does that make sense if I say that? Cruise control zone, constant speed. Okay. Now, if the speed is going up, 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 what's happening if your speed is increasing, 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 increasing? You are accelerating. You're getting faster, 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 faster. That's an acceleration. So I think about driving my car. What's happening? My foot is pushing, 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 pushing on the gas pedal, right? And so this one, if the speed line is decreasing, 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 I'm decelerating. So in my car, what's the situation? I'm probably getting to a stop sign, right? And I'm having to slow down, slow down, slow down. Okay, so let's talk about what's happening to this whole scenario. Speed is increasing. So they're accelerating. Then the speed line is flat. So what's going on when they're driving here? Constant. They're just driving along the highway with their cruise on. Now they're decelerating. They're slowing down, slowing down, slowing down. Okay, this is flat, so it is constant, but I'm not going to write that. Something else is happening there. They're stopped, yeah. Because what is the speed? 0. If the speed is at 0, 0, 0, what are you doing? Stopped. Then you accelerate again. And then you are on cruise control again. Constant speed. Okay, this time we have a distance versus time. So on this one, your distance is increasing, increasing, increasing. So what does that mean? You are going at a constant speed because your distance is changing at the same pace. So my foot is on the pedal at the same, like I'm on cruise control. My foot on the pedal is exactly in one position because my distance is moving linearly, constant. So constant speed. Constant speed, and then you're moving away from home. Okay, so this one is the same kind of pattern, but your distance is decreasing, which means you are just coming back to your home. So you're doing a constant speed, but you're coming home. This one, your distance is increasing, 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 increasing. So what's happening to your gas pedal there? You are actually accelerating on your pedal because your speed, right? You're increasing your distance a little bit, so you're not going very fast, and then all of a sudden your speed is going to increase so that your distance is increasing faster. Okay, so let's just pretend there was a number here like 40. So if you are 40 kilometers from home, 40 kilometers from home, 40 kilometers from home, what are you doing in life right now? You're stationary. There's a stop if your distance isn't changing at all. Oh, what's going on here? So labeling this, you are doing a constant speed to move away. Then your speed doesn't change in this section, so that means you're going to be at a stop for a while. And then it's back to being a constant speed away. And you take a break and you stay stationary a while. And then this would be a constant speed when you're returning. You're coming back to the home now. Okay, here's another question I have for you. In this section AB versus this section CD, which section are you driving faster in and why? You're driving faster here, and why did you pick that? Your line is steeper, right? So we've learned this about lines, about the slope. This slope is a higher slope, which means when you talk about graphs, that's a faster pace. So a higher, steeper line, the slope, you're at a faster pace. Okay, so on your charts, you're going to have to really think about the difference between the distance graphs and the speed graphs.